Let's investigate how to check for independence. So I'm going to start with the definition. Two events are considered to be independent if the outcome of one event does not affect the outcome of another event. In other words, there's no relationship between the two variables. So let's look at the situation. I'm going to make a table to see what's going on, but I have trail mixes that have peanuts in them. Some do not, so peanut complement. I've got some that have raisins and some that do not. When I'm making these contingency tables, I always put one variable as my column. And if it's the case that I have like 20 different types of peanuts, I would have 20 different columns here. But it's pretty common to have sort of that thing and not that thing. You're going to put the other variable as rows. On the outside of your table, you're going to put your totals. If you're working with percentages, you can use either the decimals or the percents themselves. Just keep in mind that when you're dealing with the totals, everything should add up to 100%, which as a decimal is 1.00. I'm going to use 1.00 because I'll need that later on when I'm doing some of this arithmetic. It's easier to do work with decimals than it is with percentages. Total of things that had peanuts was 50%. So that means 50% did not. 30% have raisins. So 70% do not. And 25 had both peanuts and raisins. I can fill in the rest based off of this. 25 and 5%, 0.05, gives me 30. 5% and 45% gives me 50. 25 and 25 gives me 50. And a double check horizontal, 25 plus 45 gives me 70. So again, the definition of independence is that the outcome of one event does not affect the outcome of the other. So the way that I like to check this, the first way, is let's see what the probability of having raisins is, and I'm just picking any event. Pick any event as a starting spot. And let's look at raisins out of those things with peanuts. And let's see if this is the same as, and now I just have to match up. I'm going to look at raisins. And I'm just wondering, does this probability change if I'm looking at different subgroups? So I'm going to figure out what's sort of my success rate for the peanut group, what's my success rate for the non-peanut group. So starting with raisins given they have peanuts. That's this first column here. Looking at this, it has a denominator of 50%, so this is out of that 0.5. And the value that I want is the raisin amount sitting inside of this. I have 0.25. So typing this into a calculator, this tells me 50% of the trail mixes that have peanuts also have raisins in them. Let's look at the non-peanut ones and see what percentage of those things have raisins. This is also out of 50%. It's out of that second column. But the raisin amount in this looks much smaller. It looks like it's just 5%. I'm going to do 5% divided by 50%. And when I do that in my calculator, I end up getting 0.10 or 10%. If these numbers are the same, if the ratio or the proportion of raisins stays equivalent for each of the subgroups, we say it's independent. If it's different, like it's different here, we say it's dependent. So raisins and peanuts being in trail mix are dependent events. In particular, the nice thing about setting it up this way is you can see what that relationship is. So non-peanut group, pretty small proportion of raisins. The peanut ones, really high proportion of raisins. So having peanuts in the trail mix increases the likelihood of raisins. And this is the whole point of checking for independence, is you're trying to see what the relationship is, if it exists at all, between variables, so you could use that for predictive purposes. Now, the second way of checking for independence is if the probability of A and B is equal to the probability of A times the probability of B, then those two events are considered to be independent. Let's try that out for this problem. So I'll have probability of, and I'm just going to pick any sort of events that I have. I'm going to pick one of these events to be A and another one of these events to be B. So let's look at the probability of peanut. And for B, let's select raisin. If it's independent, then the probability of peanut and raisins should be the same thing as the probability of peanut times the probability of raisins. Let's check. So probability of peanut and raisins, I'm going to go to my grid. I'm going to see where peanut and raisins live together. And that gives me 25%. I'm not sure if these are equal, so I usually put a question mark above things that I'm checking. Probability of peanut, well, using the table, it looks like 50% have peanut in total. Probability of raisins, looks like in total the raisins is 30%. And if I multiply 50% and 30% together here and I get this 25%, I'm in good shape, it's independent. If these numbers are different, it's dependent. When I multiply these, I get, and you can kind of see 3 and 5 gives you 15. This gives me 15%. That is not the same thing as 25%. So this tells me the events are dependent. I don't like the second way of checking. It's certainly faster and kind of easier for me to see what's going on there. But the downside is it's not telling me the relationship in the same way. I don't know if having peanuts increases or decreases the likelihood of having raisins in this expression, but I did know that relationship up top here. Finally, I just want to give you kind of a quick visual technique at seeing if something is independent or dependent. So I'm going to give you two quick tables here. A, not A, B, not B. This first table I'm making will be independent. And I'm going to have 2 and 5. And I'm going to have 6 and 15. The second one I'm going to make is going to be dependent. 2, 5, 6, 20. Let me show you why this is independent, why this is dependent, and how we can use this trick to look at our bigger table above. Ultimately, when I'm saying the proportion of raisins out of peanuts and proportion of raisins out of non-peanuts are the same if they're independent, what I'm trying to get at is that the ratios between the variables is the same. Now, in this case, I'm wondering, what would I need to multiply this 2 by to get this 6? So what is the ratio between those numbers? And to get from a 2 to a 6, I would have to multiply by 3. If this is the same multiplication the whole way down my list here, it's going to be independent. So let's check. Let's take this 5 And if I multiply it by 3, it gives me 15. It's the same multiplier. It has the same ratio. So a table will be independent if it has the same ratio for each of your subgroups. Let's see what it looks like now for dependent. To get from 2 to 6, I multiply by 3. To get from 5 to 20, I would multiply by 4. It's not the same number that I'm multiplying consistently down the row here. I have a different ratio. And that different ratio means there's a relationship between the variable. So in a lot of ways, this first way that we have of checking tells us what the relationship is and if things are independent or dependent, but this might be conceptually the hardest one to kind of get your head around. The second way is a pretty fast way to do it. This last one is a really fast way to do it, but it doesn't tell us at all what that relationship is. So let's look at the table. And let's see if it has the same ratio. From 50 to 50, well, that's an easy one to check. Times 1. So if it's independent, it should be times 1 the whole way up. Pretty easy to see that's not the case, because if I did 25 times 1, this would have to be 0.25. My ratio is not staying the same. If I multiply this by 1, that would be 0.25. Again, it looks like my ratio is not consistent throughout. And since I have different ratios, my table is dependent. So I hoped that one of these 3 ways is going to be your way of checking for independence. The multiplication rule, if it stays the same for the probability of A and B, equaling the probability of A times the probability of B. If you're checking for each of the subgroups, if the ratio stays constant, or if you're checking for the columns to see if they have the same ratio throughout. All these are equivalent, so if you establish that it's independent using one check, you only have to really do one check. But I'm giving you options to try to help you out there.